After an 8-year trek, a joined ESA-JAXA spacecraft is about to become the third to orbit Mercury and the first to deliver 2 probes at once. This is Fascinating Frontiers, episode 172. The ESA and JAXA mission will arrive at the innermost planet following a series of gravity assists that stretch the cruise phase. 2 orbiters will separate upon arrival to study the planet's surface, exosphere, and magnetic field from complementary vantage points. A new media kit outlines the final approach timeline and the instruments each spacecraft carries. Scientists expect the dual spacecraft configuration to resolve long-standing questions about how Mercury's unusually strong magnetic field is generated. The mission's arrival media kit details every remaining milestone from the final flybys through orbital insertion and the start of routine science operations. BepiColombo's arrival marks the first time 2 spacecraft will orbit Mercury simultaneously. One will map the surface and magnetic field at low altitude, while the other studies the planet's thin exosphere from a higher vantage. The dual perspective should finally clarify why Mercury's magnetic field is so much stronger than models predicted for its size. The mission's success also demonstrates how gravity assist tours can deliver complex payloads to difficult destinations without larger rockets. Watch for the first science data releases once the orbiters settle into their operational paths. Now, on a completely different note, researchers examined tiny metallic grains inside primitive meteorites to reconstruct magnetic fields present when the Sun and planets were forming. The measurements show that magnetic fields in the inner solar nebula were strong enough to influence how dust clumped into larger bodies. The work provides direct evidence of conditions that existed roughly 4.6 billion years ago. The study focuses on grains that recorded field orientations before they were locked into parent asteroids. Follow-up studies will compare grains from different meteorite classes to map how those fields varied with distance from the young Sun. Picture a cloud of gas and dust once spanning roughly 100 times the distance from the Sun to Neptune. If that entire structure were scaled down to the size of a football stadium, the region where Earth eventually formed would occupy only the space of a single blade of grass. Inside that vast but diffuse disk, tiny metallic grains began aligning with invisible magnetic field lines, like compass needles caught in wet cement. As the grains were later incorporated into asteroids and then broken apart into meteorites, those alignments froze in place, preserving a snapshot of field strength from more than 4 billion years ago. Laboratory instruments can now read the orientation of those grains to within a few microtesla, revealing that the inner nebula's magnetism was strong enough to help dust overcome turbulence and clump together. Yet we still cannot explain why the field strength appears to drop so sharply beyond the present-day asteroid belt, a pattern that shows up consistently across multiple meteorite families. Solving that gradient would tell us whether magnetic fields or some other process set the boundary between the rocky and icy worlds we see today. Engineers at Texas A&M have released a preliminary design for a lunar landing and launch facility intended to support sustained surface operations. The concept includes pads, refueling infrastructure, and navigation aids located 240,000 miles from Earth. The proposal aims to reduce risks for future landers by providing a standardized arrival point. The news release emphasizes that the facility would serve as a common hub for both robotic and eventual crewed missions. Development is still in the study phase, with no construction timeline announced. A Soyuz 21B/Fregat lifted off from Plesetsk at 0240 UTC on August 24 and delivered a spacecraft believed to be Cosmos 2619. The payload is suspected to support the GLONASS navigation constellation. The launch marked the latest in Russia's ongoing military space program from the northern Cosmodrome. Orbital tracking confirms the upper stage performed its planned burns to reach the intended navigation orbit. NASA's Perseverance rover captured a silhouette of the Martian moon Phobos passing in front of the solar disk. The event lasted only seconds from the rover's viewpoint on the surface. Such transits help refine orbital models of Phobos and demonstrate the rover's camera timing precision. The images add to a growing record of Phobos transits observed by surface assets. Scientists plan to use similar observations to monitor changes in the moon's orbit over time. Washington State University researchers trained an algorithm to evaluate millions of possible printing parameter combinations for a high-performance aerospace alloy. The system identified 6 viable approaches that reduce waste and avoid the need for extensive physical testing. The method cuts development time for components that must withstand extreme temperatures and stresses during launch. The alloy in question is intended for rocket-grade applications where both strength and heat resistance are critical. By analyzing 75 meteorite falls recorded on video, scientists traced how objects lose mass through melting and fragmentation, rather than simple evaporation. The data show distinct stages from atmospheric entry to final deceleration and ground impact. The findings improve models used to predict where future meteorites will land and how much material survives. Researchers identified 7 repeatable phases that occur regardless of the meteoroid's initial size or composition. An orbital view highlights the chain of glacial landforms extending into northern Lake Huron. The image reveals sheltered channels and coves shaped by past ice sheets. Such observations help track changes in coastal wetlands and water clarity over time. The view captures both the exposed islands and the intricate network of waterways between them. The author of The Martian and Project Hail Mary will serve as executive producer for Exoplanet, an original audio series scheduled for release this fall. The project continues Weir's focus on realistic space exploration scenarios told through character-driven stories. The drama will explore themes consistent with Weir's previous novels while reaching listeners through the audio format. A wahoo caught off the Virginia coast ended up aboard a spacecraft after its otolith was selected for a microgravity experiment on bone density analogs. The study compares calcium structures in the fish ear bone with human bone loss in space. Results are expected to inform countermeasures for long-duration missions. The otolith's selection highlights an unexpected bridge between marine biology and astronaut health research. 4 new modules let students examine data from the twin spacecraft still returning measurements from beyond the heliopause. The materials cover particle counts, magnetic field readings, and the ongoing power management decisions keeping the probes alive. Educators can access the resources through the Heliophysics Resource Database. The modules are designed for grades 6 through 12 and higher education settings. A new worksheet challenges grades 6 through 12 learners to convert one light day into familiar units using Voyager 1's current position. The exercise connects basic arithmetic to real spacecraft tracking data. Solutions guide users through the scale of interstellar distances. The problem set uses the probe's actual trajectory to illustrate how far the spacecraft has traveled since launch. Satellite and field data show that eroding wetlands from Texas to Maine deliver more than 660,000 metric tons of carbon to the ocean each year. The research links storm frequency and sea level rise to accelerated marsh loss. Findings will feed into regional carbon cycle models. The study combines NASA Earth-observing assets with ground measurements along the entire U.S. Atlantic and Gulf coasts. 2 recent papers trace how the young sun's intense flaring and the solar system's motion through the galaxy may have influenced Earth's early atmosphere. The studies combine stellar observations with geological records to identify possible drivers of past climate shifts. Researchers will test the models against additional exoplanet systems. The work suggests that both internal solar activity and the sun's galactic orbit played roles in shaping long-term climate conditions on Earth. Keep an eye on the first science data releases from BepiColombo once the orbiters settle into their operational paths. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at Narrow Network. Links in the show notes. This show comes to you from the Narrow Network. If you want another sharp daily briefing, Unintended Consequences has you covered. True stories of good intentions that backfired. All our shows are free at narrownetwork.com. The Do Positive Pod is the club for people who do something about it. Episodes and the dispatch wall at narrownetwork.com, the DPP odd. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
drifting softly through